So the question says the coordinates of point A and B are -3k, -1k plus 3 and k plus 3 comma 3k plus 5 respectively, where k is a constant, k is not equal to -1. Find and simplify the gradient of AB showing that it is independent of k. So in the first part we simply have to find the gradient of AB. Right, so gradient of AB. So the formula for the gradient was y2 minus y1 over x2 minus x1, delta y over delta x, or rise over n. So A is -3k, -1, k plus 3. B is k plus 3, 3k plus 5. Let's take this as x2, y2, and this is x1, y1. Right? Or we can take this as x1, y1, and this as x2, y2. Right? So now we just plug in the values. y2 minus y1, k plus 3, subtracted from subtracted from 3k plus 5 over x2 is -3k, -1 minus k plus 3. Right? So from this, if we compute this, we get equals to -2k, -2 over -4k, -4. And they have asked us to prove that the gradient of AB is independent of k. Right? So there must be no value of k in this expression. So if I simplify this further, if I take -2 is common, k plus 1 over -4, k plus 1, this cancels out this, we get 1 by 2, which is the gradient of AB. Hence there is no value of k in this, no k in this expression. Hence this is independent of k. Right? Now moving on to part 2, it says find and simplify the equation of the perpendicular bisector of AB. Now let's say this is our point A, this is our point B. Now the perpendicular bisector of AB will cut the line AB at exactly at its center and will be at 90 degrees to AB. Alright, so this point will be the midpoint of AB. Right? And if the gradient of AB is m, the gradient of this perpendicular bisector will be negative reciprocal of the gradient of AB, -1 over m. Right? And we need to find the equation of the perpendicular bisector P. Let's name this P. So the formula for the finding the equation of a line is y minus y1 equals to m into x minus x1. For this, using this formula, we need the gradient of the line, right, which is this, -1 over m. We need the gradient of the line and one point on the line, which is this, let's say midpoint of AB. Let's name this as x1 and y1. So first of all, let's find x1 and y1. Now we know that x1 and y1 are the midpoint of A and B. So x1 and y1 will be equal to coordinate x1 of A plus x1 of B over to y coordinate of A plus y coordinate of B over 2. Right? Now x coordinate of A was A is -3k, -1, k plus 3, -3k, -1, comma k plus 3. B is k plus 3 and 3k plus 5. Let's plug in these values. So we get x1, y1, xa, which was -3k, -1, this is xa, ya, This is xp, x coordinate to p and y coordinate to point B, minus 3k negative 1 plus k plus 3 over 2 k plus 3 plus 3k plus 5 over 2. So when you simplify this further, we get minus 2k plus 2 over 2. This is x1. For y1 we get 4k plus 8 over 2. Right? Now this is x1. This is y1, which is the midpoint of AB. So x1 is minus 2k plus 2 over 2. Let's simplify this further to make things a little less complicated. If we take negative 2 as common from here, I get k negative 1 over 2. Alright, so this cancels out this negative 1, so we get negative k plus 1 is x1. From this we get y1 equals to 4k plus 8 over 2. Now simplify this further, we get, I take 4 as common, 2k plus, no, only k, this will be, let's take 2 as common, so 2k plus 4 over 2, this 2 will cancel this 2, so we get y1 equals to 2k plus 4, and the equation of the line was y minus y1, this one, right? Y minus y1 equals to m into x minus x, so just plug in the values. We know that the gradient of the perpendicular bisector is negative 2, right? So y minus y1 equals to m into x minus x1. y1 is 2k plus 4, m is negative 2, x1 is negative k plus 1, right? So simplifying this further, we get y negative 2k negative 4 equals to negative 2 x plus k negative 1. This becomes negative 2x negative 2k plus 2, y negative 2k negative 4. This cancels this out. They both are same to both sides of the equation. The equation we left with is negative 2x plus 2, which is the equation, the perpendicular bisector of AB.